to Calculus 1 on this glorious Saturday morning. We are in section 7. No, yeah, section 7, chapter 4. I was right. We're talking about L'Hopital rule. It is a way to take derivatives. And I like to start with the limit when x, I don't know why, okay, x goes to 0 or sine x over x. So at some point earlier in the semester, I asked you to memorize that the answer for this is 1. And you all did, which is nice. Today is the day when we take a look at this rule, which will tell us how to compute limits like this and similar ones. So let's state first that, so this would be a theorem. It says if limit x goes to c of some f of x, so if limit f goes to c, whatever number is there, it can go to 0, 2, can go to infinity, can go to any value, right? Has this property that f of c, that f of c is either 0 over 0 or infinity over infinity, then limit x goes to c. Actually, I have to rename this. All right, I'll fix it up there. Prime of x over g prime of x. There we go. Supposed to write f of x over g of x has the property that f of c over g of c, when you just need to compute. So you just plug in and compute. And you have the example right above. As I plug this 0, you get 0 over 0. Now we know we can't compute that because it's divided by 0. So we used different methods in 2.3. We did either the chart or the graph, or we used algebra to cancel, rationalize. So we did what we could, right, to solve. But then algebra is not going to work all the time. You might not have graphing calculator all the time, and be ready to do those 13 different steps to graph the functions and so on. So maybe there is an easier way, right? And this is the easier way to figure these problems out. So this is what L'Hopital's rule is. Now please note, and this is very important, I will write this actually down. You are not doing the quotient rule here. You are taking two independent, separate derivatives. Derivative of the numerator, separate completely from derivative of the denominator. And that's clearly written in the notation. It's f prime and then g prime. We know that the quotient rule is, right, g f prime minus f g prime over g squared. This is not a quotient rule. So let me write that. Note, we do not use quotient rule. Right? These are separate derivatives. So now I'm immediately going to solve this problem. Limit sine x over x as x goes to 0. You memorized that the answer to this limit is 1. And here is the work on it. I'm going to put red zeros, which means as I computed this at 0, I have 0 divided by 0. We call that the indeterminate form. So now I will place L apostrophe H on the equal sign. That's the notation, which means that you are now using the L'Hopital equivalency, which means the derivative of sine x is cosine x and the derivative of x is 1. This limit is clearly 1 divided by 1, which is 1, and that is the answer. So these two functions, sine x over x and cosine, are not the same functions, but they have equivalent limit. You will never have same functions once, well, obviously if it's e to the x, right? But you will never have the same functions emerge on the other side. What you're going to have is a different function, completely different function, whose limit is going to have the same value. That's what you're going to have. So all of the problems that we are going to deal with today, we are going to have indeterminate form, 0 over 0, or infinity over infinity. Those are the two main ones. But then we are also going to look at 0 times infinity, infinity minus infinity. That's a very interesting one. You can make this to be like 3/4 or something, or 0 or infinity. They can subtract into technically anything. That will solely depend on functions. And 0 to 0, 1 to infinity, those are also there. And infinity to 0. All of them are kind of tricky, right? Because you know that any number multiplied by 0 should be 0, any number multiplied by infinity should be infinity. So what happens when you combine two of those? Which one is stronger, right? And the answer to that actually depends on the function. The same thing here, right? Oh, that should be, wait, infinity minus anything is infinity. Anything minus infinity is negative infinity, but then infinity minus infinity, can that just be 0? Again, the answer is it could be 3/4. We'll see the problems. Anything raised to 0 is 1. But then 0 times 0 times 0 times 0 should be always 0. So what is now 0 raised to the 0? Again, depends on what kind of functions you have laying around. So, you know, these are really mind-boggling problems. And I always enjoy this section. You're going to learn a method. We're going to apply ln to both sides and have lots and lots of fun with this. I hope. I mean, at least I will. I don't know if you know. But it's Saturday. It's nice. Look at that. Are you guys awake? By the way, there is 10,000 people in this room. You can only hear 2 laughing right now. So, indeterminate form. Let's take a look at examples. There is a proof in a book if you're interested. Again, not an honors course, so if you're interested in the proof, just look at it. So let's take a look. One more time, what are you looking for here? You are only and always looking for to have 0 over 0 or infinity over infinity. If you get any one of these, you have to massage those expressions into the basic ones. The rule that we are learning applies only to these two. Anything else has to be transformed into those. So we are learning how to transform them using algebra. So we're not coming up with any special calculus deals. You will need to know how to take derivatives, obviously, and then eventually how to take the limit. So let's take a look at random problems from textbook and see what is going on. For instance, it really doesn't matter. Problem 16 says a limit. I'm not going to rework the ones that are done in the book because you know all the letters and you can just read that, right? There's no reason for me to read over those. E to the x minus 1 divided by x squared plus 3x. So you can't use chapter 2 other than charts, which is annoying and long, or graphs, which is also, if you don't have a calculator, issue. And you don't have the calculator, graphing. So we look at this and say, well, we know that the basic way to do any limit problem is to just plug the value in. If we don't get 0 or anything weird in the denominator, that's the answer. If you get the finite number, I don't know, 7, you're done. So you plug in 0. E to the 0 is 1. 1 minus 1 is 0. So we have 0 here. And then you plug 0 downstairs in the denominator, and it's 0 again. So because you have 0 over 0, that's the basic indeterminate form, you can apply L'Hopital's rule, which means that the limit you have will be equivalent to the limit when you take derivatives of numerator and denominator. So e to the x is e to the x in the derivative, and we have 2x plus 3 in denominator. Now, you plug 0 again. This is like having a new problem. So technically, restart the procedure, plug 0 in. If you have 0, 0 again, you do L'Hopital again. How many L'Hopitals you can do in a row? Well, as long as you can. As long as it's 0 over 0 or infinity over infinity, you can do L'Hopital's rule over and over and over again. As soon as you get off of that track, that's it. Well, we're off of that track because now e to the 0 is 1, so we don't have 0 in the numerator. But then when you compute, you see that it's just 1/3. So the limit is 1/3 for this. These problems are really nice, quick. 20. You saw something like this in your chapter 2 problems, you'd probably be running for your lives. Look at this. X goes to 2 pi. It says x sine x plus x squared minus 4 pi squared divided by x minus 2 pi. You see how awesome this is? That's great, right? Well, let's try. When I plug in 2 pi, sine of 2 pi is 0. So the first term is 0. And then 2 pi squared is 4 pi squared minus 4 pi squared. They cancel. The entire numerator is 0. 2 pi minus 2 pi in denominator is 0. So I have 0 over 0. And I can take the limits. The derivatives, because I can use L'Hopital rule. So limit x goes to 2 pi. And now, when I'm taking the derivative, I have a product rule on the first term. So what do I have? Copy the first, derivative of the second, minus, copy the second, sine x, derivative of the first is just 1, and then plus 2x. What happened? Oh, the pen's passed. Don't worry about it. Divided by derivative of x is 1, derivative of 2 pi is 0 because it's a constant. So that's it, right? Now we test again. Cosine of 2 pi is 1, so the first term is 2 pi. So sine of 2 pi is 0, and this is going to be 4 pi at the end. So it looks like it's a 6 pi on top. divided by 1. Wait, it's 6 pi. Done. That's the answer. Thanksgiving dinner is approaching, guys. This is the problem you should bring up. Here, you can enjoy one of these. How about 27? Try this one on your own because you can. What happened? I did. 3. Now you got this. You got this. Look, it's e to the x minus sine x. Nothing to worry about. Minus 1 divided by x to the 4th. You got this. Plus 8x cubed plus 12x squared. All you need to do is to, as 9 cubed says, just do it. There you go. You text the guy. You text the guy. Chris. Which one to buy? Ben? Yes, yes. Ben? What? Me. Doll. What? Yeah, my doll. Just saying it out loud. I was just listening. I'm doing the same. I can't hear you from like, you never noticed that about your own name. Yeah. That's D. There you go. Well, I know that's an N, but it looks like I know it's supposed to be an N, so it looks like an N to me, but it does look like a W. I checked my 3-year-old son. Yeah, W. There's the W. Right there. Josh? Oh, no, we still do. You got some fun on this. Oh, yeah, so it's supposed to be. See, this is an N. Brian. Brian? Where you at? Where are you at? I'm right here. We're right here. Oh, there. Another one? Another one? Again. How is this one? Okay, so the bottom's not going to be there. None is not here. Don't know. Oh, no. You sign up for Calc1?
It's maybe the action in class, right?
Yes, it's going to be very.
You know who's teaching when they say to be announced or like?
It's going to be adjunct because everyone from full-time staff signed up already. So if it says to be announced, that means that they still.
How long to be announced?
Probably another 2-3 weeks.
Yeah.
Yeah.
Yeah, I'll show you.
What level for the
engineering. Night class, but I don't want to.
Could be Mike Hadovich. Could be Mike Hadovich because he's the adjunct instructor of physics.
I mean, A doesn't take an A class.
If they
I work.
if they don't get anyone, I'll just drop my calculus to and take that one.
I think I'm taking copy, but.
All right, let's take a look at this problem together. You got your homework back. So we start this with computing first. So e to the 0 is 1. Sine of 0 is 0. And then 1 minus 1 is 0. Good. And then we have 0 in denominator, which means that we can use L'Hopital's rule, which are independent derivatives. So derivative of e to the x is e to the x, thank you. Derivative of sine x is cosine x. Derivatives in denominator are 4x cubed plus 24x squared plus 24x. I'm going to check 1 minus 1, it's 0 again. Each term has 0 in denominator, so it's 0. I can use L'Hopital's rule again, which means one more L'Hopital rule here. Limit, take derivatives again, independent. So e to the x is still e to the x, and then we have plus sine x divided by 12x cubed plus 48x, and then plus 24. Now the denominator will not go to 0 again. Numerator will be 1. So it's 1 over 24. I hope you all have that. 1 over 24. 4 looks like a 9. So let's make it that way. Since you love tricks so much, how about this one? So limit is approaching pi over 2 from the left. We have tangent x divided by 3 divided by 2x minus pi. This is actually in the textbook, so hold off on your hate mail. This is a real problem.
Fun or cosine, I heard that. Yeah. So you compute the cosine. Fun over there. Which two? Which two?
I don't know.
Square.
So, yeah, I know that, but, okay.
The secant is 1 over
So you're
cosine.
saying 1 over cosine
And then whatever you get square that.
squared, okay.
Divide it with the cosine.
Do it again.
And again.
So we're in the right side.
So another,
Oh, we're in the right side.
another
Yes.
derivative.
Right, so we know this. Or this is more than here.
Because the derivative of that.
Oh yeah, we just doing that from there.
Oh, this is
1 over cosine, right?
This and this.
Yeah, are you?
How?
What did they say? Yeah, so they, this one of these,
So, the H something.
oh no, no, we have to buy it.
5 on the efficiency. Let's take a look at this problem together. How much is tangent of pi over 2? Yes. And then we have 3 divided by 0, which is infinity, which means that we can do L'Hopital's rule. So this will be limit. X goes to pi over 2 from the left. That's the little minus sign up there. And derivative of tangent is? Very good. And now we have derivative in denominator. We can use the chain rule for this rather than the quotient or anything. We copy 3, and then we have negative 1 times 2x minus pi to negative 2. And now we can simplify this. Don't forget the limit. Pi over 2 negative. We have secant squared I can write as 1 over cosine squared x divided by negative 3 divided by 2x minus pi squared. Now I'm going to use algebra to bring this 2x minus pi in the numerator and cosine, well, negative 3 cosine, sorry, negative 3 cosine squared x stays. Just make sure that the stream is going. Yay. So now we compute again. And as I compute pi over 2, the top is going to be 0, and the cosine bottom is 0. So we can do L'Hopital's rule again. So what's happening now? In the numerator, I have 2 times 2x minus pi times the derivative of the inside. Ooh, I forgot that here. Derivative of the inside is times 2, right? There is another 2 that floats around, so this is negative 6 and negative 6. All right, so 2x to the 1 times 2. I forgot the limit. Wow, that's minus 5 per line. Again, drop down 2 for the chain rule, 2x minus 5 pi to the first power, and then times 2 with the chain rule from the inside. And derivative down negative 12 cosine x, and then derivative of cosine is negative sine for the chain rule. So all of this together is 4 2x minus pi divided by I can just say sine 2x. So 6 sine 2x. Remember that the formula 2 sine x cosine x is sine 2x. So I just combined all of that stuff. We try again. So when I plug in pi over 2, this is 0. And pi over 2, sine of pi is 0 again. We do L'Hopital's rule again. This is great. The derivative on top will only be 8 in this case, because derivative of the parentheses is 2 times 4. and down we have the sign is cosine, and there is a 2, so 12 cosine 2x. Awesome. Plug pi over 2, cosine of pi is -1, so it should be 8 over -12, cancel by 2, -2/3. Just -2?
But I did it right. I just converted this tan x into sin x by 4 times. So you're gonna have to do the
Yeah.
3 times. You just have to do it once and you get it.
I'm wondering if I forgot the 3 somewhere, but because we are factor of 3 off. There might be a constant somewhere. So you have -2 or +2? What did you say? What do you say? +2 or -2?
-2.
You have -2.
Yeah.
All right. So let's put it like this, and then remind me during the review session. We'll do this problem again a different way. We have a lot more of these problems to deal with, but this is one of the ways. Now let's take a look at a different form. Zero times infinity. This is mathematical manipulation. F of x is equal to 1 over f of x. So this is just a mathematical manipulation that we are going to need for this particular situation. So let's take a look at the example immediately. That's all it is. Limit x goes to 1 from the left, 1 minus x times tangent of pi x over 2. That's the problem. As you plug in 1, 1 minus 1 is 0, and tangent of pi over 2 is infinity. So you have 1 times infinity. Now remember, only 0 over 0 and infinity over infinity use L'Hopital's rule. You don't have that. So we are going to use the trick up there, f of x, to change one of the two. So I can either write 1 minus x as 1 over 1 minus x, or I can write tangent as cotangent. So it is any one of those, and it should be working. Now 1 over, I mean those. So it doesn't matter which one we pick. So we're going to use the f of x is equal to 1 over f of x, and we're going to get limit x goes to 1. Which one do you want to flip? Trig or non-trig? Non-trig. So tangent pi x over 2 stays where it is, and this one becomes that. So now we test again. Tangent of pi over 2 is infinity, and you have 1 over 0 infinity. So you have infinity over infinity, which is the setup for L'Hopital rule. Don't forget to put the limit. And now we take derivative. Derivative of tangent is secant squared pi x over 2, and then we have pi over 2 in front. In the denominator, we take the derivative. We can use the chain rule because this 1 over 1 minus x can be written as 1 minus x to the minus 1. So we kick out negative 1, and then you have 1 minus x squared, and then you have the derivative of the inside, which is another negative 1. So this simplifies into limit x goes to 1 minus, and what I'm going to do is I'm going to keep the pi in the numerator, secant squared pi x over 2, and then negative 1 times negative 1 is gone. This was supposed to say negative 2 here, and the exponent. And I have 2 over 1 minus x squared. Oops. Just more algebra. Limit x goes to 1 from the left. What do we have? Pi 1 minus x squared. In denominator we have 2 cosine squared pi x over 2. All right, so let me explain what happened here. So it's just algebra, constantly algebra. I have pi that stays where it is. This is in the denominator of the bottom fraction, so 2 that are far apart multiply, so that goes on top. Secant is 1 over cosine, so that's going to go here with 2. And that's it. So now we compute again. Cosine squared of pi over 2, that's going to be 0. And you have 0 in the numerator, so it's 0 over 0. L'Hopital again. Yay! Because we have 0 over 0 again. Don't forget to write the limit. So 2 pi of 1 minus x to the first power, and then there is a negative 1 because minus x chain rule. In denominator we have 2 cosine pi x over 2 times the derivative of this negative sine pi x over 2 times the derivative of the chain pi over 2. Nice. These cancel. Pi and pi cancels, and the 2 is going to go on top. So limit x 1 minus 2 1 minus x divided by cosine. Let me write sine first so it's easier. Sine pi x over 2 cosine pi x over 2. And now I can condense that if I had another 2, so I'll multiply top and bottom by 2. Shouldn't have canceled them. Limit x goes to 1 minus 4 1 minus x divided by, and this combines down there into sine of pi x. That was the double angle formula. Plug in negative 1. I have 0 over 0 again. We're going to do this 15,000 times until it actually works. Derivative on top is going to be -4. This is definitely, it stops here. Cosine of, so pi, cosine pi x, and I have -4 as the derivative over pi. Because when I plug in 1, it's positive. Cosine of pi is -1, so it will be -pi, -4 divided by -pi is 4 over pi. That should be it. A complete hush in the crowd. It's just algebra. A lot of it. This was actually a real problem from the textbook. I'll go through this step by step. Try to get at least half of a smile on someone's face. That's fake. You can drop it. Drop the fake smiles. And let's go through this exercise of the mind. All right. We are exploring 0 times infinity case. As I mentioned, for those of you who just showed up, working on L'Hopital's rule, and we have all of these different indeterminate forms. The two main ones are 0 over 0 and infinity over infinity, which is where the L'Hopital's rule apply, where you can take derivative of the numerator, derivative of the denominator separately from each other, and the new problem, new function you get is equivalent in limit, but it's completely different. Now, we also have these 5 indeterminate forms here, which have to be changed into these 2, so the L'Hopital applies. So if you ever run into any of these, there has to be some kind of algebraic manipulation. No calculus here whatsoever. Your calculus is taking the derivative or taking the limit. So the problem we just did is one of the 0 times infinity, which is not a basic form. And we have this manipulation here where you say that, like 3 is equal to 1 over 1 over 3. This would multiply the top, and then divided by 1 is it, right? So that's exactly what I'm using here, because I have 0 times infinity when I plug in 1. I am using this, and I can switch, in this case, either one of these two. So you pick this one, fine. The other one would be much faster, because we just cotangent and you're done. But that's fine. So pick that one. And now when you run -1, you see it's infinity over infinity, which is indeterminate form, which means that we can hit it with L'Hopital immediately. Take the derivative. Derivative of tangent is secant squared. It's not a quotient rule. Separate derivatives. 2 separate problems, detached from each other. So this one derivative separately from this derivative. I did the tangent, which is secant squared, copy the argument, and then derivative of it as a chain rule, pi over 2 in front. This one I can write as 1 minus x to the -1. I don't want to do quotient rule on this. I can just use the chain rule, which is much easier. So that -1 exponent drops. 1 minus x to the -2, and then times the derivative of the inside is in a chain. -1 times -1 is 1. So I only have this, which goes in the denominator because of the negative, and I have the 2 that drops down. So 2 over, and that's the denominator. And now I test -1, ends up being 0 over 0, right? Because, look, I can put this one up, and secant squared is 1 over cosine. So cosine goes in denominator. 0 over 0. So now I have 0 over 0 when I compute. I can get derivatives independent. So 2 drop in front of the pi. So 2 pi. 1 minus x to the first power. And then derivative of the inside is -1, which is where the negative pops from. Divided by derivative in the denominator. Derivative of cosine is sine in the chain rule. So you have cosine squared, right? So that goes in front, makes that Oh, what happened with the 2? Ugh. All right, so it's not 4, it's 2 over pi, the answer. I forgot one of the 2's. You see, if I copy this one, when I do the derivative, this one drops in front as well, so 2 times 2 should be 4 over here. And then I don't have to do this later, the times 2 to make it for the, yeah, all right, I'll fix that. So this should be 4. Actually, I can fix it now. So this one over here is supposed to be 4. Then I will not need to do this because, hold on, this one canceled, so it doesn't exist. This 2 exists, so this 4 doesn't exist. Okay, how many mistakes do I have here? 7? 7 mistakes? When I take this derivative, the 2 will drop, make it a 4, and then cosine to the first power times the derivative of the inside, which is sine, times the derivative of pi over 2. And I have over 2. Oh, that's the over 2. This one over here is the one that goes on top. And I want to leave them because I need the one on the bottom to condense this into sine double angle, which kills this 2. So there is a 2 here. So this becomes negative 2, and the answer becomes 2. All right, awesome. So what happens now is when I take this derivative, you know how this 4 becomes what it is. 2 and 4 will cancel, and I will have this 2 is the one that comes from here up, and then pi is canceled as well. And now I condense this 2 sine cosine is 2 sine double angle. So when you multiply this by 2, 2 drops, so it's just pi x there. And then we test again 1, that's 0 over 0. So L'Hopital rule one more time. This distributes as 2x, 2 minus 2x. Derivative of that is negative 2. On the denominator, pi drops in front as the chain rule. Derivative of sine is cosine. Plug in 1. Cosine of pi is negative 1. So negative pi, negative 2 divided by negative pi is 2 over pi. It's much easier when you do this as a student because you don't have to talk about it. You just do it. Yeah.
Do you mind explaining how you get from 2 sine and sometimes to sine?
It's double angle formula. Sine 2x is 2 sine x cosine x. Right? Write it down. Sine 2x is equal to 2 cosine x sine x cosine x. So 2 sine x cosine x, right? So that means that this, and we are running that backwards. So that means that this one will be just doubled, right? Which loses this one. So it's sine pi x. So this is the only trick, guys, that you have to memorize. This is the only trick that you have to memorize for 0 times infinity. This 1 over f of x. That's the only trick that exists for the entire group of problems. So, to recap, when you see 0 over 0 or infinity over infinity, those are the main indeterminate forms. You unleash L'Hopital upon it immediately. If you see 0 times infinity, you will have to use, on one of those factors, you will have to use 1 over f, and that will get you immediately into the form where you can use L'Hopital's rule. The next one on the list is infinity minus infinity. The trick that you have to memorize for this one is factoring. Remember, the only form that you are allowed to use is 0 over 0 or infinity over infinity. You have subtraction. So to get the division from subtraction, you have to factor, which makes multiplication, which is the previous case, and then you use 1 over f, right? So it's factoring plus 1 over f. What does that tell you about the potential length of these problems? Right? It's one step more than this, right? Yeah, guys, it all depends. These problems could be literally 3 lines because, right, the functions were not as bad, or they could be page and a half if they are. That depends on the problem, not on the method. But clearly, infinity minus infinity is subtraction, and the way to go from subtraction to division, remember, it has to be division, right? Because both forms that you are basic are both division. So to get to this form, you have to factor first. That will give you multiplication of hopefully 0 times infinity, and then you will unleash 1 over f trick to fix it. Let's factor a little bit. They only give you 4 problems in the textbook. I'll do 1 out of 4. You also have 1 in examples that you can read. And then try the other 3 and ask questions about it, obviously. So which one should I do? 51, 52, 53, 54. Here they are. Maybe I should do one of the non-trig ones because they're trickier than the trig ones, actually. They're all the way top left. 52 or 54? 52? All right.
Wait, 54. They both want the exact same.
There's an X on both.
Well, I'm going with 52 because they'll be the exact same, and the earlier ones are usually easier. Yeah, just do 54. Get it over with.
Get it over with. How much pain do you actually have? It's calculus, guys. It's not like you have to lift anything heavy. Okay, let's see how my head works, and then see if you can replicate similar. I have subtraction. I know I need division. So in order, this is how I work the problem backwards. So I know what to do, where to start, right? So I say, okay, in order to do factoring, I better have an x here so that I can factor x. To get x outside so I'm able to factor, I see I have x squared, but I don't have x squared here. Because if I have the x squared here, I can factor x squared, which escapes the square root as a basic x, and then I can factor x there, and then I would have multiplication of 2 terms. And then I can do 1 over f to finish everything off. So the only issue is that this is not x squared. How do I fix it? Well, x squared, x, right? So I multiply and divide by x. Only this term, times x divided by x. That will give me x squared, which factors here as with this x squared, and then drops out as x. And then I can factor that x out. It's kind of nested factoring. But I have to fix the term in order for all that to happen. So that's why these problems are a little bit tricky to see that progression. So what I'm going to do is I'm going to divide over here by x and introduce the square on this one. This is how I'm fixing the problem, so it fits what I need. Then I will factor x squared, which escapes the square root as x. Now, I would obviously skip all 3 steps here, but I can't. So I'll out, just bear with me. Here's me factoring x squared. Then I am kicking that x in front of the square root. And then I am kicking x in front of the parenthesis. Yes. Is stream alive? Nope, stream is offline. Okay. Stream complete. Uploading. Whoop, stream resumed.
Yeah.
Okay, stream is resumed. Let's see if it's... Okay, it caught up. It is a network, so I think they're updating network or anything else. If I just had the Surface Studio here. Oh, man. Life would be different. Okay, we are live and it's green. So, okay, everything is hopefully working. So we have this procedure. I will explain this one more time. So we are starting with a problem and we need that x squared in the parentheses so we can do the factoring. I start with fixing that with x over x, which gives me x squared. Factor out x squared in the second line. Then x squared escapes the square root, becomes an x, and then I factor that x. And look what I have now. I have x, which is the first factor, times the parenthesis, which is the second factor. And now I test what's happening here. When I plug in infinity, clearly I have infinity here. 4 over infinity is 0. So I have 1 minus 1, and 1 minus 1 is 0. So I have infinity times 0. It is here that I use 1 over f trick to put this 1 over x in denominator. Leave the square root on top. So 1 minus square root of 1 plus 4 over x, and then 1 over x in denominator. So now when you test infinity, you get 0 over 0, which is indeterminate form, which means that you can unleash L'Hopital's rule to get equivalent problem. So now we're taking the derivative. Independent derivatives. So remember, the derivative of 1 is 0. You have a negative number there. Square root. So now this derivative is very tricky. It's a nested chain rule. So you have to be very careful. The derivative of a square root is 1 over, it's going to be negative 1 over 2 times the square root as is, times the derivative of the inside, the square root, and that is negative 4 over x squared. Does this make any sense? Because chain rule, right? And then derivative on the bottom is just this. So negatives will cancel off, x squares will cancel off, and you are left with limit x goes to infinity. Oh, 2 and negative 4 will reduce as well. So you will have negative 2 over there. So now you have what? You have negative 2 divided by square root of 1 plus 4 over x. And 4 over infinity is 0. Answer is negative 2. So we just did a problem where infinity minus infinity gave you negative 2. I find this awesome. So what's the correct answer when someone who never sat in a calculus class asks you, what is infinity over minus infinity? No. depends on functions. It can land on any number. It depends on types of functions, depends on constants that are involved around. You can make it into 3/4. You can make it into anything that is possible there. It can also end up being infinity. It could end up being 0. It could go anywhere. Depends on functions, the types, and the constants that are floating around, and so on. Just by changing in the original problem this into, I don't know, 6, that might be -3. I don't know, but probably something like that. So you will, try, and then you can actually go and retrace the problem with 6 and see if that's actually going to work out to be -3 there. Probably you can adjust very easily. So 4 out of 7 are done. 2 basic ones, and then 2 hybrid ones, 0 times infinity, infinity minus infinity. We are left with all exponential ones, but the cool thing is that for all of those 3 indeterminate forms, it's the same trick, and that trick is ln both sides. So you write as y equals the limit, you apply ln on both sides, and that's what takes that exponent. If you remember your ln logarithmic differentiation, each one of those exponents was a coefficient that multiplies in the derivative. We are using pretty much the same trick here. We take the ln of both sides and we drop the exponent down. So let's see how that works. I'll probably do 2 examples for this. And whatever you get, it's always going to be the same procedure. If any one of you watched my Calculus 2 streams, you saw this actually come up. And at that point, you probably said, I will never take Calculus 2. But it's just, a step in a problem which you are learning how to do right now. So we have some awesome exercises. What is the limit of sine theta raised to the tangent theta? We will use ln, yes. So now I'm going to work on 1 to infinity, 0 to 0, and infinity to 0 forms. And the method for all of these is apply ln and then good luck. So the first problem that I want to do is a proof that you are supposed to memorize today and know it if you're taking more math courses later on. Because it actually becomes embarrassing in Calc 2 if you don't know this. It's one of the huge results in mathematics, and you should know it. Limit x goes to 0 of 1 plus 1 over x to the x. Now you're going to see this usually with n goes to 0, 1 over n to the n. So what is this limit equal to? Remember the words I used. Embarrassing, if you don't know this. It's like asking you what is 3 plus 2 when you go... How do we do this? Well, you set this equal to y. And then you ln both sides as the problem is asking you. Now observe that the y is equal to the entire problem. So if I come up with, I don't know, y equals to 4, right? Then that's the answer, 4. I won't come up with 4, but whatever, just said that. Now, what I'm going to do is I'm going to copy ln y is equal to, I'm going to put the limit in front, and then I have ln of 1 plus 1 over x to the x. And this is the part where I can use the formula, if you remember it. Ln x to the p is p ln x, which means that this x that was in the exponent can go in front of the ln. So ln y is equal to the limit x goes to 0 At this point, I just want to cry. It's not 0, it's infinity. It goes to infinity. This is the problem when I have too much sleep. I really exhausted myself yesterday, and then I just slept forever. So now I'm just not functioning. Yeah, that's the problem. This is the problem. It has to go to infinity. Wow. All right, such is life. Let's go.